Yes, welcome to my YouTube channel. I am excited to share with you a project that I've been working on. I coined the project A AI as a legal assistant, and the project is an AI agent where you can ask different questions concerning the laws in Rwanda, and then it will give you an accurate answer, depending on the laws that we have in Rwanda. So how it works is like you go to the agent, and then you type a case. You might have a defense case, or you might have another problem. Once you ask it, then it's going to go make a research, look for look for like the cases that are almost as yours. Like, let's say, maybe is it a stealing case, is it a case about different other issues? So if that's the case, then it's going to look for past cases, see what the judges have made as a decision, and then from those past cases it's going to get all of that, and then get the laws in Rwanda, then gives you a recommendation, tells you maybe you should you should be very very much worried because you did something which is, yeah, damn. All of it tells you like, don't worry, bruh, you're fine, everything is good. So yeah, how did I come up to this particular project? I The project was when I was learning fine tuning, I was recommended to do a project, and rather than just doing the typical projects that you are asked to do, I like those in class like to do and all of that. I just had to create. I decided to go my own way, where I created a particular model that is only based trained on the Rwandan laws. Now, why did I choose this project? Because really the Rwandan laws are not, you can't find any data set, so it gave me the skills to learn like data set design for models, then also like processing PDF files, finding the information, the right information, all of that. Then the model required for in order to create the agent, I had to also like learn about LLM ops, and these LLM ops then give me the like they give this is where I get the accessibility, or this is where I give it the API access, where a user can just where a user can access the agent without an issue, rather than just having a model on Hugging Face and then everything is done. Yeah, so that was the reason. But for the motivation behind the project, it's I was talking to a friend of mine, and he wanted to buy a new car, but he was looking for like what are the laws governing buying a car in Rwanda. What are basically That's the overview of the project. Let's I'm excited to share you everything about it. Now let's dive deep. In terms of how the overall project is built, when a user makes a request from the front end, then the request is sent to the DeepSeek chat review agent. Then this review agent has different tools, two tools. The first one is to find the relevant cases. Then it's going to go find all relevant cases and then read the case documents. After it reads the case documents, it's going to build an accurate context. Then it sends it to our API. So this API is how we exposed our model so that you can easily consume it. Then the API is going to also forward the request to the model. the model is going to understand the understand the prompt. Then it's going to return a response, same, but this time when the API returns a response, the response is going to go to the front end. So there is no need for the DeepSeek review to do another review again. Yeah. What we're going to do, first and foremost, we have to load our data set. Let me see if I can increase the size. Yes, we have to load our data set. Thereafter, we specify which, this is where we are going to save our data set. And then we have to specify the document. We have to specify like the PDF file, where is the document. Thereafter, here I'm using an English speller. This is a Python dependency that I saw, which helps us to check if a text is in English. So why do we need something like this? It's because if you see, there is a Kinyarwanda version, English version, and then a French version. Now I want to ignore all the others, all the other languages, when we choose for English. So this is why we're using an English speller, and it's going to go look at each phrase. Then whatever it sees an English phrase, it's going to say everything is good. Whenever it sees a phrase which is not in English, then it goes back. Yes. So this is what this function is doing. The validate English phrase. I give it a phrase, and then it's going to look at each part of the phrase, which is the word, and then it's going to check. Here you have to consider something like Rwanda is not an English word if you look in the dictionary, according to the dictionary. So what you have to do is that you have to add such exceptions, so that whenever it sees Rwanda, because otherwise nothing will be put in. If a law contains Rwanda, like Rwandans, Rwandese, Rwanda, then it's going to, that one will be ignored. And because I want to keep track of what happens, everything that is ignored is going to be put in a log file, so that I can verify after. Yes, this method build dataset dict is in order for us to format the inputs, or like the rows, as DeepSeek would want it to look like. So DeepSeek expects us to have a collection of JSON objects in our dataset that look like this. So they must have an instruction, an input, and the expected output. So for our case, for example, the instruction is explain the law article as mentioned in the Rwandan Gazette, official gazette. So I provide this gazette. You might be giving it the legal law, or not the legal law, the labor laws. You might be giving it different other laws, but so this is going to be extracted from the page title. Then input, how is the article text list. So this is going to continue. Yes, this is like the article, the summary of the article. You can see on this part. For example, for this article, we are looking at, this is the part that I'm saying, how is the deprivation of civil rights of part 1. So these articles are classified into parts, subsections, sections, and all of that. So of part 1, part, title, chapter, section, and if a subsection exists, is explained. Then the output should be the output of this. Let me show you for an example. Page 50. Yes, this is a small example. So for example, how is article 3, no punishment without law, of chapter 1? Then of course it's going to, the part was already captured, will be already captured part, and all of that explained. Then this is the the next part, which is we are going to pass it, which is the article.list.text. So this list contains contains two things: the summary and then the explanation. Yes. So yeah. Now looking at the article dataset, this is where we are building our dataset now. What we are doing is we are going to first initialize the result. This is going to contain all the data, all the JSON objects that we will need for our dataset. Then we initialize all the what we need, all of these like the part title, the chapter, all the variables that we are going to need. Then for the first page, we want to get metadata of the first page. So this one, so that we can get like what is this row and all of that. Let me share this one. So we want to know what is the gazette, what is the number, and all of that. So we can build our first metadata. So the first page we just split, then we look at the information. First of all, we look for the text official gazette, and then we just set the title. After that, then we look for the text that starts with low determining. So yeah, here, as you remember, I'm using the pure PDF to read the documents. In this case, it's enough because we don't have like visuals and all of that, and it's faster. So we can't use something like OCR or yeah. Then we don't need to use something like OCR. Then yes, then we are going to, this is the law. Here we are looking for the text that contains digits. The text, what are we looking for here? Then we're looking for the text that contains digits, so that we get this. So we need to get when this was like properly established, the law and all of that. Yeah, this text is what we are looking for. Then we make the metadata. We are explaining the law date, basically everything. We make the metadata. What is the summary about this law? And then we give the law date and the text of this, which is law determining the file. So we give it the first element in our dict is to give it the first this information. Thereafter, we are going to now look through all the files, and here we start off from page 44 because these are just summaries, like what's included in the document. But starting from page 44 is where now we have the explanations. So we want, starting from like this page up to here, then we want to consider everything. So that's when we extract the text on the page. After extracting the text, we are going to split all the text into, because these are like double lines, we are going to split the text, then obtain after splitting the text, we are going to look for, is there something like a part, is there like a title? We hold all of those. So whenever we split a text, we are going to, whenever a page is information is extracted, we want to see if the part has changed, if the title has changed, if the chapter has changed, if the section has changed, or subsection. So we always need to check. And lastly, we always have to check if the article has changed. So we are reading up to the moment we get to this article, then it means the article has changed. So then that's when we need to do another pre-processing again. We say, okay, again, we are going to append this. Whenever the article has changed, then we are going to build the dataset, and then we upload. We are going to format it using this method. After that, then we are going to send it to upload it to our result, to add it to our results. Sorry. So after adding it to our results, then we are going to initiate the article text, because this article text now we needed is the one which is saving all of this, saving this, the title and all of this. Then we are going to clean it again so that we can start from scratch again. Yeah, so that's all. Then yeah, we initiate in the main, we just call it so that we get we are going to return the result. Then we are just going to call it here. Then we use pandas to create our data frame, our data set basically, and then we save it. We save it locally. Now after this, I will upload my data set to Hugging Face. I've uploaded my data set to Hugging Face so that anyone can access it, can update on it and more. Yeah. So how did I fine tune the model? I used Google Colab to fine tune because my PC is not that powerful yet. At the start, I just have this notebook where I install all the necessary dependencies, then import all the dependencies, and I set up my token. So here I'm setting the environmental, like the Hugging Face token, to get it from the one that I've passed here in the secrets. Then I'm going to initiate like the model ID, the bits and bytes config, and then the tokenizer and the model. So here we are going to use the roller technique to fine tune our model. So that's why we are setting all of these parts. Then I start by trying to ask a question, and you can see, for example, asking it this question, we get information, but more like it's going to show you specialized, like generalized information. Yeah. Then yes, these are the roller configs. This is where I'm setting all the roller configs, and now I pull my data set, and yes, once after pulling the data set, I'm going to get a small sample of the data set, and then split it up so that I can get ones for training. Then yes, if for example you check, you can see this is the one, some of the parts that I'm going to use. And then format. So now here I'm just formatting everything, so like using the same format, like putting it in a text, in a small text. But remember that we have the format that we used. Then now I'm going to initiate the trainer. This is the define the trainer. We are using supervised fine tuning trainer, and then we give it its configs as needed. Then also pass it the roller configs. This then after like defining the trainer, we are going to do the actual training. So you can see has this part takes so much time, and then after that I will save my pre-trained model to a custom name so that I can either upload it to Hugging Face and also use it as I want. Then here I'm going to generate a response based on the model that we've trained, and then you can see now it gives more of like a generalized, not a generalized, more like it gives you like a specific response, and give you like understanding from the context, plus also understanding from the rules as they are described, or from the roles as they are described. Yes, now we are going to look at how LLM ops and how I do inferencing. So before using Modal, I tried different things like Orama and AWS, and the cost was higher compared to this one where they give you free credits and to try out the platform and also look at it. Plus, it was recommended by a friend of mine, and it's easy to get started with. You can look through the docs to understand how it works, look at how the integration with LangChain and all of that. But in my case, for example, I have this model. I push my model there. Then after pushing my model there, then I can run inference there. So I generated my own a script. I had support with Casa here. Then I would basically I need to load up the application. You know, the application that you've created for the project. Then you generate an image. So what image? This is like the like a Docker image, if one would say, that you're going to use. That's like what are the dependencies that you need there. Now then you create a cache volume, and you initiate a class for model inference. So this one is I'm going to use the L4 GPUs. These are the ones that do not burn the that do not use much credits. So you can try the T4 like GPUs. They are going to take so long to load up the response. But if you use something like L4, there is a balance between the credits that they use and also the response time. Then a timeout of 6 and then all of the parameters that are needed. Then the big thing is about this class. So this is the model. This is where you are building the model logic. And then the first thing is to load up the model so that model can access it and do all it needs. Then I have to get it from Hugging Face. One thing I saw about the LLM ops, because my PC is not that powerful, everything I have to pass it either to Orama or to mostly Hugging Face, so that I can pull it from there. So I have to push everything on Hugging Face so that I can pull it from there. So you can see even here I'm already pushing it to Hugging Face. Plus also in production you can't tell it to look at your locally, so you have to put it on Hugging Face or another place. So I put it on Hugging Face, then I set up my Hugging Face information. I specify the model that I need. Plus also here I don't need to give the token, because to clone them or to like get a model from Hugging Face, really, as long as you haven't set up much like restrictions, anyone can do it with no need to be authenticated. Then I load up the tokenizer and then the model. After loading the model and the tokenizer, I use because we're using the Roland adaptation. This is the base model that I'm loading. So this the DeepSeek. This is the base model that I'm loading, and the way now, because what I built was not like the entire model from scratch. Rather, it's a Roland adapter that I created, and then it's the one which is going to be put on top of the model so that it's fine tuned. So this is this is loading up my model, like my adapter model, how you call. Then I merging the adapter weights. Then I do the model and then merge all of that. Lastly, then I have different methods. So this model, remember we have a class model. I have different methods. This method is for generating like if you want to just tell it create or give me something like no, you give it a prompt and then you wait for an answer. This is the method. This is how we handle this case. So you can see, give me this ABCD, then it comes, it does all of that, and then it asks the model to generate based on the input that you give it. But now we have another method which generates a stream. So you've seen like how when you ask ChatGPT, it like gives you answers in parts as the model generates, gives you answers. So this is where I'm handling that case, so that the user doesn't have to wait like so much time to get a response. Rather, the moment the model generates a response, then it gives it already. So here I'm using what we call SSE, server sent events, so that we can send and capture all of those. So yeah, this is, you can look up how to implement this, but I will show you in the API section how to implement this. And also, yeah, then the web generate is to just give it an API if you want to create an API, so that you can just use the API from Modal. But for me, because I want to create the SSE and I have a backend server that is going to do some like other things. So yeah, I created everything on my server. Now yes, now we can look at the API. Now in this particular part, we are going to look at our API. So in our API, basically we have just your plain fast API. Yes, fast. You have your plain fast API, and we just have a normal implementation where you have something like we have two methods, the two endpoints. The first one is for health check, where you are seeing if your API is okay. Then the other one is to handle the the server sent events. So this is whenever we run inference, and then the model gives us any particular gives us the message, then we are also looking at it at the same time, sending it to the client the moment they send it to us. Now, looking at inside the server sent events, how do we call the model? So Modal gives us a way. Modal gives us a way to like call our model or like interact with our model from our script. So here we have to initiate. We initiate it so that with each endpoint request, we don't have to initiate it always. So we initiate it at the top. Then we make a model. We instantiate the model. After instantiating the model, now we say, okay, model is equal to our model again. Oh, this is actually not needed. Yeah, I can remove I should remove this part. Yeah. Then what I'm going to do is, this is not needed. So what I'm going to do is I'm going to listen for each chunk that I receive from this method. You can see here, I'm calling this method. Then I'm looking at the like remotely generated. After giving it the question, I provide, so yield. This is how we implement server sent events. You can look it up how you implement it, but this is for like this is for like when you receive the message, you just make sure that you dump it into a JSON format, then you send it. Like all of this, always sending this. Now after sending all of this information, now I send it to the user. You will see also how we handle this on the front end. One thing you have to note here, which is good to know, is that it's better to mock this method. So before, when I was testing, when you're testing, you're doing a lot of calls, making a lot of calls. I didn't mock this method. And then my tokens, I had $5, and with using L4, your call is like 2 cents or 3 cents. I ended up initiating so many calls that I was remaining with like $1. So this is something that I learned through this journey, where always make sure that you mock this method before you do the actual thing. So you can do the actual thing like once or twice. Just make sure you mock this method. Yes, so for the front end, it's just your typical normal front end where you would just you ask, implemented in using Next.js, where you would come and you say, okay, I want something like this. Maybe systems with the case where I was caught stealing a pen. And then once you send the request, it's going to go to the front end. So it's going to create like a chat, a new chat, then it saves the chat to your local host so that you have access to the history. So here I didn't want to create a new like database and all of that to make so much, because it's easy to clear the local host. So now what's happening is that our model it's making a request. First of all, uh, we are going to, like I mentioned in the architecture, it's going to look through DeepSeek. DeepSeek is going to go use the tools to find all the information. After finding all the information, it's going to now start doing stuff. We can wait a bit to see how it's going to happen, and also we see the server sent events coming. After that, then we are going to So when the model receives your request, what it does is going to ask DeepSeek. It's going to ask the first agent to make a research about your case. So what the first agent does, it's going to come to this particular portal, looks for all the case laws that are related to your case. For example, in our case, it was about stealing. Then it looks for cases that involve stealing, for example, this one, and then it reads through what was made as a conclusion, so what the court has done, and every information about this particular case. Once it finishes reading the relevant cases, then it's going to send it to our model, and then our model is the one that will give you a particular guidance. So then you see, remember the server sent events, you saw how it was sending. That's how the implementation. But you can see here, I try to use few related cases so that I can reduce the amount, how big the prompt is going to be. But you can see, for example, it's going to see all of this, looks at the relevant articles. Then it's going to look at the applicable precedents or court cases that had similar things. You can try something for like maybe murder or something else, some other crime that you might have committed. Then it's going to make a recommendation and give you reasons why the recommendations, and also give you the next steps that you can do. So this is a small example of how the front end works. Now let's look at the implementation. So inside the implementation, what I do is I have the page. This is the landing page. It's your TP connects JS application. So we have I'm using the app router, and then frame a motion to just give it a small motion. Then this is this is the landing page. Really, you can read through everything, but what I want to show you here is the chat component. So whenever you click on the chat, it's going to prompt you. So here it's going to create a session. Whenever you click the chat, it's going to create a conversation. So it's basically your conversation. It will create an ID. So on this part of the click handle the send. Once you finish clicking send, we create a conversation. After creating a conversation, we just start saving the conversation using the generated ID. We just start saving it there, and the ID is going to be the key, and then you push the user to the conversation. So that's why you see already after doing that, you just push them to to the chat loud with the conversation ID. Now inside here, what's worth a highlight is that I use a custom hook in order to handle the callback. So in order to handle the server sent events and also the like interaction with the models. So you can see once you receive a question. So on we will see all of this, but basically implementing, you start with the streaming. I want to show you like when I want to keep track whenever you are streaming, whenever something is happening, and when it's done, when the agent is done, when the the API call is done, so that we can pause the streaming. So here is it receives a question. You use this send message callback, which will receive a question and possible options. Then after that, it's going to initiate a controller. You start the streaming. Then we make a call to our research agent. Our research agent is basically this implementation using LangChain and DeepSeek chat, so that we can it's going to make a functional call. After getting the functional call, it will respond. It will give us the different user cases, relevant cases, and recommendation for the next our advisor model. And to find the relevant cases, we basically use this tool. The first one is the find relevant cases, which is going to goes on this. So on this platform, I use their APIs to find the relevant information. So the first one is API. So this one, for example, is the one that finds relevant information. No, not relevant cases. Oh, yes. So this one, for example, is the one that is going to we are using to find the relevant cases, where we are going to search for the particular case that we got, and then you can see it's going to look for us, gives us all the cases that are related. And one information we like that is the model is going to like is about this file like highlight. So it's like a summary about the text. It's not well structured, but it's the one that we have. And now another one is the read PDF file. So once we get the case, we are also interested in the ID of this case, and then we use this particular API to find all the information about that. So to find all the information about that particular case, and mostly interested in this file URL. So here in this file URL, now I have an API call, this one. So handling the file reading, I used also the server to make an implementation. It's the same thing like we did for reading the normal document. The document is just that we're loading it from it's the same thing when we try to read the information from in the data set, but it's the one thing is that the difference is that what's different is that we are loading it from the URL. Now after getting this document, I pass it to I pass the document URL and then get the response. Now in my agent, when I build the prompt, I give all the information about the prompt and then tell it about the tools. So you can see I'm informing it about the tools, what should be what to expect using the tools, and how to use the tools. So this is the one, but this one requires special attention so that the agent knows how to use it easily. Then after, so we were on this part after getting the information from the research agent. Now we pass it to our main agent, which is the API call. Which is the API call that we are doing. We give it the instruction. So here also I'm giving it an instruction, but based on the research and the user question that we have. So all of this, I just give it. You can check out my GitHub to read through all of this information. And then once I get this, is now where I'm going to get the server sent events. If the response is okay, now I start to resend to the events that will be sent. Now, listening to the events, what I'm going to do, I initiate a buffer. Then, every time I get to read, I just check if everything is done or if I have a value. If we are done, then I need to stop streaming and break the while loop. Otherwise, it can stay as an infinite loop. Otherwise, I put everything in my buffer and then I start to get the chunks, to read the chunks. So whenever the current line in the buffer uh, has data. Remember when we are sending from the data from the backend, we had data dot with two dots to give me. We have data with two dots and then the message. Now this is what I'm getting, and then whenever I receive a chunk, I always send a chunk. You will see all of this. In these options, you see the on chunk method. Then also, once everything is done, now I call the complete method, and if an error is there, I just call the error method. Now you can see in my send. So now again, I have another chat model where I have another chat component on this part. When we have started this one, when you click send here, what happens is that we call the onSend method in our hook, and then on a chunk, whenever we receive a chunk, we set our current message. So this is to handle the state here inside this component. So we set the current assistant message to this, like the previous plus the new chunk now, so that it can append. It's like appending the string. Once everything is completed, we just now append this to our general messages that the user is having in the conversation, and then we clear the current message. If an error happens, then we append also an error message and clear the current pages, and now we update our localhost. Key point. So a user can ask a follow-up question. Once they ask a follow-up question, now we are going to append so that you don't lose the information. And if you load, for example, if you reload or maybe you close your browser and you come back to this, you always have your history. So this is why we are sending it to the localhost. If you reach to this level, use a real one. So yeah, kudos to you. Like and subscribe for the project and for the channel. Helps out the channel a lot. Yeah. So this is the part for the reflections and all of that, and the lessons that I've learned through the project, which is I really learned a lot. I enjoyed myself working on this project. Not in the part of saying I was very happy from this. No, it's you say you've enjoyed as a developer. You say you've enjoyed looking back at it, but during the time sometimes you're about to kill someone. So yeah, that's the part. So I think for me, one thing that I truly liked working on this project was when you're learning a new skill. So this is something that really resonated with in this project, where I was doing model deployment. So after I fine-tune my model, I had to put it to serve it on a platform, so to put it on a platform so that a user can access it through an API. So this was not easy. Definitely was not easy. For the start, I tried to use Orama, and Orama failed. So Orama locally was working. I hosted the model on Llama, but then the price to initiate an API and do all of that was not that. Yeah. Then Hugging Face 2, I saw the prices. That was crazy. Then I opted to go for AWS. But then on AWS, I also saw like the latency. So what is there in LLM Ops is like for example, if you're buying the T4 GPUs, it's going to be very, very slow. it's going to be super slow. The answer you might wait for like 5 minutes before you get the first chunk of the answers. Then you have to opt for L4. So L4 seems to be faster, but also comparatively cheaper. So then L4, you find that it's a bit expensive. Now I came to Modal. Modal has free credits. Five. You get started with $5 of credit, and then yes, depending on the GPU you're using, they reduce the amount of money. So it gives you that part of saying the flexibility for you to first start, check how the pricing works, check which GPU can work for your use case, and then you start with that one. So I truly appreciate that about Modal, but their documentation is not as easy as you would do any other documentation. Because and also this is where I saw how new age learning works. So when I was deploying to Modal, their documentation is very, very, very hard to interact with. For me, for me it was super hard because it's new. I was new to this. Then what I found out there was that using Cloud Code, I gave it the documentation. I gave it the basic functionalities of my model, how it works, and then I said I want to do this. I want to get to this level. Then it gave me the initial template, the initial bandit. I read through. I asked for it to document everything, and also for me to I took the time to first understand the deployment guideline, then put everything there. If you asked me even now at the top of my head, do you remember this part and this part? I know because I read through. Then I would ask it, where in the documentation is this written, so that I can go and further read through that part to that part, and then it guided me through, and I was able to implement the SEC. So when I wanted to integrate SEC server sent events into my model deployment, into the deployment guideline, then I was able to add it on my own without requesting like the cloud code to add it. So I was truly happy with this one. So yeah, definitely I took so many lessons from this project, and I hope to apply them to my next projects going forward. Thank you.